So 5, 4, 3, 2, 1. Okay. So in this question that I asked you, okay, so you're asked what's the physical state that has a definite volume but no definite shape. So mostly all of you answer it correctly. It's a liquid. A solid has a definite volume and a definite shape. A gas has no definite volume and no definite shape. Okay. So where did we stop last time? I think we already started in
We stopped on like sig figs.
significant
Yep.
figures, right?
Yep.
Stopped
Yep.
at where it was significant figures. Yeah. Okay.
Like the scientific notation part.
Okay.
I have a
So
question. For our homework, is that posted on the blackboard or do we do that on Owl? Like,
it's
where do
OWL. Most of your homework is the OWL. Okay.
Okay.
I will tell you if we really have another homework of this kind, because the way that we do is if I'm going to give you an homework, you're going to submit it, it will be hard for me to grade 96 students. Okay, so what I do, the type of the homework that I have is just like quiz.
Okay, so the homeworks are just quizzes?
Yep, you're going to take it outside class R. That's why you could say it's still a homework. Okay.
Okay. So like the assignments when you go into like
Yep.
chapter 1. Okay, so okay.
So the one that you have quiz for chapter 1, you're going to do it after Thursday.
Okay.
Okay, because you need to run it with a Respondus lockdown. So what does it mean? When you take it, the lockdown, the Respondus lockdown browser should be the one you're using. So this is a dry run for your
You cut out. I didn't
exam.
hear what you just said, Professor.
You just broke out. You like broke up.
Okay, so
Yeah.
so what I'm telling you, the chapter quiz that we have, that is your homework because you're going to take it outside class R. And the first one that will be given will be after Thursday. And you're going to take it with Respondus lockdown. So you can take it anytime you want after class. Okay? But you only given 10 minutes once you start answering it. Is that clear? So it's a 10 question. So it can be multiple choice. It can be true or false. Okay? As we go on, there will be questions on what we call calculations. But right now, I make the chapter 1 quiz more on multiple choice or what we call true or false. Okay? So that's some sort of dry run for you. So let's start with this one already, because later on, somebody will ask the same question again and have to repeat the answer again. So we're just wasting time tackling those stuff. Okay. So we have started on these so-called significant figures. So we said the number of significant figures refer to the number of digits reported to the value of a measured or calculated quantity indicating the precision of the value. So if I'm not mistaken, we already go over the zeros, right? The rule on the zeros.
Yes.
Yes.
Okay. So what we're going to do now is, what's the rule that we have if we do the calculation? So when multiplying and dividing measured quantities, we give as many significant figures as the least found in the measurement used. So what does this mean is when you do division and multiplication, the final answer, okay, the number of significant figures for the final answer depends on the least number of significant figures in the given numbers. Okay, I'm going to have a specific example on that later on. There's a slide for that. And then when we do addition and subtraction, measured quantities, what we do is we give the same number of decimal as the least found in the measurements used. So Multiplication, division, the least number of significant figures. Addition and subtraction, the least number of decimals in the given measurements. Okay, so let's try to do multiplication and division. So as I've told you, the number of significant figures in the result is set by the original number that has the smallest number of significant figures. Okay, so if we going to have a calculation like this, 4.51 times 3.6666, and you're going to get an answer like that one. Okay, so you're going to look how many significant figures the given number has. So you have 4.51. Okay, so that means you have to write this in terms of what? 3 significant figures, because this one has how many? How many significant figures this one has? 1, 2, 3, 4,
2.
5.
2.
Okay, so if you have the 5, you have the 3, so this one should have how many significant figures?
8.
3.
3.
You have
3.
3. Because you have 3 and 5, so 3 is less than 5, so you have to round it up to 3 significant figures, giving you 16.5.
Okay.
So is it significant figures or the amount of decimals after?
Okay, so we're doing here multiplication or division. So the one that we're looking at is just the number of significant figures. So the one that has the least number, that's the one that dictates the final answer. Okay, now let's try another one. 6.8 divided by 112.04. So if you're going to use the calculator, that's the answer that you have. So the question now is, what is the, how are you going to write the final answer? So you have here how many significant figures?
2.
2. And this one?
5.
5.
5. So how are you going to write the final answer?
With 2.
0.1.
0.1.
1.
1. Anyone else?
I thought it was
Anyone else?
0.
What did I say? Anyone else? What's the other answer that you have?
0.060.
0.06.
0.06. What else?
0.060.
0.060?
Yeah.
Or 1?
1.
Oh, yeah.
So which is the right answer here?
The second
bottom
one.
Second.
0.06.
Okay. So if you're going to be in the exam and this is your answer, the one who answered this one is correct.
Okay.
Question. Why this is wrong? How many significant figures do you have here?
1.
1.
1. How
That's
many significant
two.
figures do
1.
you have here?
1.
1.
How many significant figures do you have here?
2.
2.
2.
Period.
Okay? So before you react, okay, think first. You can react later on because there's a poll question about this. Okay? Right now, you're 96 students. I cannot have the chance to deal with each of your questions. But the one that I want to do is you learn what is the right one. Okay? Show me that you learn by answering the poll questions right. I'm recording the poll question. That are your quizzes. So right now you have already what? 4 questions that you have answered, including the one last time. Okay?
Okay.
So how about the other one? Addition or subtraction? So we already have the multiplication and division. Okay? So what is the rule that is different for addition and subtraction? If multiplication and division deals on the number of significant figures, addition and subtraction don't deal with that rule. Okay? the answer in addition or subtraction cannot have more digits to the right of the decimal point than any of the original numbers. So what does it mean? You have to look at the number of decimal places. So the one that has the least number, okay, after the decimal point, the final answer should be like that. So for instance, if you do a calculation like this, 89.332 plus 1.1. So if we're going to look at the given number there, okay, so the final answer should have the same as the one that has the least number after the decimal point or to the right of the decimal point. So we could say the final answer should have one significant figure after the decimal point. So in that case, this should be right as what?
90.4.
90.4.
90.4. Okay? Because this one has how many? 3
That's 3.
significant figures after the
right.
decimal. And this one is 1.
1.
Not because you have a number 1. Okay?
So for when we want to do significant, we always do the one with the lower amount.
Well, it depends, as I've told you. Okay? The thing is, you know what the rule is if it's multiplication and division, and you know what the rule is if it's addition or subtraction. And in both of them, it's the least amount, but you have to be clear what's the least amount. So for addition and subtraction, that's the least number of significant figures after the decimal point, but while for the multiplication and the division, that is the least number of significant figures for the whole given number.
Okay.
Okay, so let's try this one. So how are we going to write the final answer for this?
0.79.
0.79.
Okay, so if you're going to look at this, how many significant figures after the decimal here?
2.
2. And this one?
4.
4. So we always go with
The smallest.
the smallest or the least number of significant figures. So this we need to write as
0.79.
0.79. Are we clear on that?
Yes.
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 Could we use our calculator for the quiz?
Yeah, but as I've told you, the quiz that we have is more on, we do it what we call simple one, and then we go to the complex one. Don't worry, when you go to chapter 3 and chapter 4, all of them are all calculations.
I have a question. The quiz is next Thursday, correct?
After Thursday.
After Thursday. Okay, never mind.
You're going to take it after class. Please leave the questions about those things afterwards.
Okay.
Okay? That's when the time everyone will be listening.
I have a question.
Yep.
So you know how you said we can use a calculator?
Yep.
For the response lockdown, if we look away, you get an alert.
Yep.
Is that fine?
It's fine.
Okay.
It will give you a flag, and during that time, I know what's the question that is being asked.
Okay, thank
So
you.
you have to be very careful that if you're flagged, make sure you are doing a calculation, because if you're flagged and the answer, the item that you're answering is not calculation, you're going to be penalized on that. I don't really care how you take the exam. I only look at the video when there's a flag. And what I do, if the flag, what we call fall on time that you are dealing with calculations, I said, yes, he did that because he's using a calculator, some sort of. Okay. No, as much as possible, no music during exam. Okay. Yes, question, Kyle.
So will that quiz will be available all day after class on Thursday?
Yep.
I just have a meeting right after class. Okay.
It will be available up to the weekend. It's just that when you take it, I want you to have the best time that you don't have any disturbance during that time. Okay? So let's talk about that later. So let's try to do this, and then we have 2 more poll questions. So measurement and significant figures. So how are we going to answer this? Is this the right one?
Yes.
Is this calculation right? So this is what?
Division.
Division. So
It's
this is
not
division. So you look at every number, at all numbers. So this is how many significant figures?
3.
It's not right though.
3.
Isn't it 1 point?
Yeah, it's not
And
3.
this is
4.
4.
4.
Oh, it is. It is.
Yeah.
It is
It's
right.
1.4, right?
It is right.
It's 1.3.
14.0
It is
divided by 102.4.
Can
Is this right?
yes.
Yes. Yes, it is.
That's right. I'm just testing you if you understand, okay, the thing. Now, let's go to our second poll question. Okay, so you ready?
Mm-hmm.
Yeah, you have 1 minute. Whoa.
Oh, shit.
Why are all numbers moving?
I get. Yeah, I regret my answer now.
That's why think before you press.
Then you overthink.
But you said 1 minute, so I panicked.
That's why. So 10, 7, 6, 5, 4, 3, 2, 1. So let's see. So you know our exam questions are multiple choice, right? So it's already given me how you understand the concept. So how many significant figures are there in 20.05?
5.
5.
5.
5.
So how come 35% answered 4?
Probably because
The last 0.
A lot of
Did
people
not
call
take
the
the
last
final
zero.
0 into account.
Okay. So what zeros are these? What do we call them?
Trailing.
They're the captive one. The hostage. And any captive
so they become
zero,
significant figures.
yeah.
Yeah.
Okay.
Okay. So it
And
was
then
5.
that's why you include them. Okay. How about this zero? What do you call this?
That's the trailing one.
Trailing.
The trailing one. And when does the trailing zero become significant?
When a number
When it's
After-
after when there's a decimal. After a
When it is
decimal.
after a decimal.
Hearing.
Okay. So all zero after the decimals are significant.
Significant.
So if you're going to look at
Get
this, so
into
you
it.
have 1, 2, 3, 4, 5 significant figures. Okay?
Okay.
Okay.
Zero.
So you have 1 minute to press the correct answer. This is not how fast you answer.
But you
How
say a
correct.
time. When you say a time, I automatically go into panic mode.
What did I say? 1 minute.
You said 1 minute, and I was like, okay. It's
And
time.
this is how this is what the 5th question that we have. Okay?
Yeah.
It's understandable. It's the first time, but this is the 5th time. Okay? So let's go on the concept of this exact number. So when we have an exact number, this is a number that arises when you count items or when you define a unit. So when you have an exact number, so usually, okay, when you say you have 9 coins in a bottle, you exactly mean 9 items. So if we have a calculation, let's say conversion, so when you say there are 12 inches in a foot, you mean exactly 12. Okay, so when you have an exact number, it doesn't have any effect on the significant figures in a calculation. So what does it mean? When you have an exact number, you just ignore, okay, that exact number, because you're not going to count the significant figures of that exact number. They are exact. So when you have an exact number, their significant figures is infinite. Okay? So when you're dealing with an exact numbers, okay, these are the definition, the number of objects, the conversion factor. We consider them to have an infinite number of significant figures. So if we're going to get the average of 3 measured lengths, 6.64, 6.68, and 6.70, is this the correct average?
Yes. Yes.
Yes.
Yes.
Yes.
Because the 3 here is what?
3 numbers.
Division.
It's exact.
It's
Yeah.
an exact number. So usually, the final answer that you have has the same significant figures as any of these 3 that is given. And it just happened that all of them has how many significant figures?
3.
3.
6.
So you ignore this one because this is
Inexact.
an exact number. Okay? But usually, if you are confused, what is the answer that you usually put here? And this is?
Wrong.
Wrong.
Incorrect.
Okay? Because you might say, oh, there's a 3 here. So the 3 here is what? One significant figure. But the 3 here is defined as
Exact number.
Yeah.
Why is it exact number? Because it's a number of the measurements. Okay? Remember that, because this is one thing that most students got wrong when there's a question like this in the exam. Okay? Now, are you ready for another 4 question? This time, you need a calculator.
Bring it on.
Bring it on. Okay? So you're going to need your calculator here. So I'm giving you 90 seconds.
Thank you.
Because you have to do the calculation to answer the question.
One, two, three.
That was a tricky question.
No.
Yeah.
Yeah.
20 seconds.
Regret my answer.
15. Okay. Time's up. Okay. So before we answer the question. Let's try to solve the problem. So it is 3.14 times 2.751. And divided by 0.64. So this is the technique that you should know. If you have a calculator like what I have, okay? So what I do, I just input all the experiment, all the values that I have, and then wait for the final answer. So if I'm going to input 3.14 times 2.71, 2.751, I'm going to have an answer like 8.638. I'm not going to round it up. What I do, okay, I just use a whole number and divide it with 0.64. So what's the one that will come out?
I got I got 13.
Maybe like this. But the question is, what's the right answer? If you follow the rule that we have only just established, how many significant figures the final answer should have?
2?
Yeah, I put 2.
The answer is 2. So
Because
how
the
are you
bottom
going
number
to
is
write
2.
this one?
13.
It's 13.
It's just 13.
I did 13.5. Let's see.
No, you have to follow the rule there. What do you have? 3, 4, and 2.
Two.
Well, I thought we were supposed to ignore that one.
Why do we have to ignore that one?
We only ignore it when it's exact number.
It's not an exact number.
I thought you meant just.
Okay? How do you define an exact number? A counting number and a defined number. When you say a defined number, like a conversion factor. Okay? So I think if we go by the date, the time that we have here, only 50% will pass this course. Consistently, it's 50%. We always get the right answer. Okay? So remember, if ever these type of questions come out the exam, you should be able to get it correctly. Because if you still get wrong, so that means what? You still don't learn. First time you'll find, second time, maybe not good. Okay? So, if we're going to continue here, now that we know these significant figures, we go to this concept of accuracy and precision. Okay? So when do we say one is accurate? When do we say it's precise? So when you are accurate, okay, it means your measurement is close to the true value. So if you have an analogy of a target here, the bullseye there, that's your true value. If you are close to the true value, then you could say you are accurate. Now, precision, on the other hand, has something to do with how close the set of measurements that you have with one another. So if it's close to one another, you could say it's precise. So if you have a target that hits the bullseye and close to one another, then you could say it's accurate and precise. But if your measurements are far from the bullseye, okay, but close to one another, you could say it is precise but not accurate. And if you have this what we call kind of target, they're spread out, they far from the bullseye, so your measurement is neither precise nor accurate. Okay, so between accuracy and precision, they said it's easier to get precision, because the problem with accuracy is what? You don't really know sometimes the true value. Okay, and usually when you deal with accuracy and precision, you also have to deal with this so-called error. So error is how close, okay, your value is to the true value. So in accuracy, we could say the error that we have there is the difference between the true value and our value. Okay, and they said there are two types of error. One can be systematic, and the other one is random. So when we're talking about systematic error, it causes data to be either what? Higher or lower than the true data. Random errors, on the other hand, from the word random, it could be higher or lower than the true data. Okay, so accuracy and precision, we usually use it interchangeably. But if you're going to look at the true meaning, they're not really the same. Okay, accuracy is how close your measurement to the true value, while precision is how close your set of measurements. Okay, now in the measurement that we have started last meeting, we follow the so-called SI units. So in 1960, the General Conference of Weights and Measures adopted the International System of Units. Now you might say, international system, but what we call acronym it as SI, because it is in France, the way that they call it is Système International, which is a particular choice of the metric units. So in the international system, they prepare the metric system. Okay, and this system has 7 SI-based units. And from these SI-based units, you can get the other units, which we call derivative units. Okay, so what are these magnificent 7 that we have? So we have here the length, whose SI unit is a meter. We have here the mass, whose SI unit is the kilogram. Okay, we have time, whose SI unit is the second, and you have temperature, who has the SI unit in Kelvin. So as of now, these are the things that you should know. Okay, and if you have taken high school chemistry, there's an SI-based unit called the amount of substance, which is mole, that you're going to learn in chapter 3. Now, electric current, we won't be able to use it at this level, okay? And the unit that you have there is ampere, while luminous intensity, okay, the unit that you have here is candela. So luminous intensity is if you have this LCD, okay, the projector that they use. Electric current, that's the current that you have usually in electricity. So the one that you're going to use at this level will be the first 5. So remember the SI unit that they have. Okay. Now, if we're going to look at the SI units, what makes this practical compared to the other system is the so-called decimal system. Okay. So the SI units usually what? They always has this power of 10 conversion. So a larger or smaller unit is indicated by an SI prefix. And that is a prefix used in the international system to indicate a power of 10. Okay. So if you're going to look at this base of 10, usually you can convert one unit to the other by just using the prefix. And the common prefix that some of you may have encountered already are this one. Okay, so you have here mega, kilo, deci, centi, milli, micro, nano, pico. So all you need to do is just use this prefix and then put it in front of whatever unit that you have, like kilo. So we can always put the kilogram here or the kilometer. Okay, or there we can put here microgram or put here milligram and their centimeter. So these are the common SI prefixes. So if you go higher, you might have what? 10 to the 9 giga, 10 to the 12 tera, okay, and 10 to the negative 15 femto, okay? But you may ask, do we need to memorize them? I would say just I think this one that's listed here, the practical one, because you're going to need them when you convert, okay, them from smaller to higher units. Now, what is practical in using the so-called metric system? So the United States, unfortunately, don't use the metric system. It used the so-called English system or imperial system. So if you're going to look at the imperial system, look at the conversion that they have. It's just like a roller coaster. So there are 12 inches to a foot, and then there's 3 feet to a yard, and then there's 1,760 yards to a mile, or there's 16 ounces to a pound. But if you're going to use the metric system, all of them has a base of 10. Okay, so there's 1,000 millimeters to a meter. There's 1,000 meters to a kilometer. There's 1,000 grams to a kilogram, and there's 1,000 kilograms to a ton. Okay, so that's how the difference between the two. Questions so far? Before we go in each of these unit.
No.
So unfortunately, US is not part of the metric system. Okay.
Because it's too big.
So temperature. So in the temperature, we usually use the Celsius scale or the formerly the centigrade scale. Unfortunately, that is not the SI unit. Okay, what's the SI unit in temperature?
Okay.
Kelvin.
Kelvin. Okay, so the SI base unit of temperature is Kelvin, and Kelvin is based on this so-called absolute temperature scale. Okay, and the conversion from Celsius to Kelvin is simple, since the two scales are simply offset by 273.15 degree. Or we could say K is just equals to whatever is the given Celsius or centigrade plus 273.15. Okay. Now there's also another scale that we use in temperature, and we use it here in our country, and that is the Fahrenheit. Okay. And the conversion of the Fahrenheit to Celsius and vice versa can be accomplished with the following formula, like this one. So if a Fahrenheit is given, you want to get the corresponding Celsius, so all you need to do is what? Plug in Fahrenheit minus 32 equals to 1.8, or divided by 1.8, and you get the corresponding centigrade. Now if you have a Celsius that is given, you multiply it with 1.8 and then add it with 32, and you will have the Fahrenheit. Okay, so this is another scale, and this is commonly used here in the US. Now, if we're going to compare the three, okay, temperature unit, this is how it looks like. So the water would boil at 373 Kelvin or 100 degrees Celsius or 212 Fahrenheit. It freezes at 273 Kelvin, 0 degrees Celsius, and 32 Fahrenheit. Okay? Now, let's try to compare it the easy, funny way. When it is Fahrenheit, when you say 0 degrees Celsius, it's just really cold outside. And if it's 100 degrees Celsius, what we call Fahrenheit, it's just really hot outside, like the West Coast at this time or earlier this summer. But if you say Celsius, if you have 0 degrees Celsius, it's still fairly cold outside. But if it's 100 degrees Celsius, you're dead. Okay? Because 100 degrees Celsius is equivalent to what? The boiling point of the water.
Oh, so too hot.
Okay? So do you think you can be alive by that temperature?
Nope.
Now for Kelvin, if it's a 0 Kelvin, then you're dead because that means absolute zero. If it's 100 Kelvin, you're still dead because that's what? Negative. What is the equivalent of 100 Kelvin with Celsius? If you're going to do the calculation, okay? So 100 Kelvin there minus 273, so that is equals to negative 173 Celsius. So that is so cold. Okay, so that's the, we could say the difference if you're going to deal with the number. Now let's go on the derived units. So as I told you, there are what? 7 base units. Now the other units are just operations dealing with those 7 units. So for instance, the SI unit for speed is what? Meters per second. So that means speed can be defined as what? How do you define speed if you have meters per second? Length over, what's the base unit?
Time.
Time.
Over time. Distance over time.
Okay, so that's meters over second. Okay, so speed is just an example of a derived unit. It's created by combining 2 SI base units. Volume is another one. And usually volume is what? Cube meter. Because where do we get the definition of the volume? Length times width times height. And all of them are what? Meter times meter times meter, which will give you cubic meter. But usually what do we use for volume? We use
Liters.
liter, which is a unit of volume equal to 1 cubic decimeter. And it says here, based on the equivalent, 1 liter is equals to 1 cubic decimeter, and 1 ml is equals to 1 cubic centimeter. What's the other way that you do the 1 ml? If you are in the hospital, what is cc? Carbon copy? It's just the same as that one. It's just cubic centimeter. Have you noticed it whenever you're in the hospital? How many, what volume are we going to use? So they use what? cc.
Yes.
But it's just cubic centimeter. So they just get the first C here and the second C there. So giving you cc. Okay? Now we go with the density. So density of an object is its mass per unit volume. So this is mass over volume. Okay? So density is a physical property. What does it mean? Knowing the density of a material, you can identify what your material is, because a material usually has a specific density. Sometimes they call it specific gravity. Okay? So the unit of mass that you have there is gram, and the unit of volume that you have there is ml. So this is for solids and liquid. For liquid, it is ml. For solid, it's cubic centimeter. For gas, it's liter. So this is, we could say, for the gas. The way that you do is gram. And then you have gram per cubic centimeter. So this is for solid. And then gram per ml. That is for liquid. Okay? Now, in the practical way, we can use the density of a given material to have an idea on the relative density of another material that you mix with the given material. So what does it mean? For case with water, anything that floats is what? Denser or less dense than water?
Less dense.
Less dense.
It's less dense. Anything that sinks has a higher density than water. So for instance, this one. So what can you say about the relative density of copper and mercury?
Copper is less dense than mercury.
Can you say it like that? This is a density. Okay. So what does it mean in terms of density? Maybe I'm going to show you a video here that would help you identify density. So I'm trying to get some sort of a video. Where is it? So I'm going to have to share screen, you share. So maybe you're familiar with this character, not this guy.
Oh, I remember this scene. I don't think we're supposed to hear it.
Can't hear it.
Who thinks sand is as heavy as gold? Come on.
There.
He could have
What
used
does
a
this
rock.
mean?
Sand is less dense than gold.
What does the film clip means? It means that Indiana Jones didn't take Gen Chem 1.
Exactly.
Okay? What's the problem in what he did?
He tried to use sand as a comparison for metal.
I don't think it really matters what substance
They both did the same density.
what substance he used, as long as it was the correct weight.
Yeah, but the problem is, I don't think they have the same weight.
No,
I
because
think the sand was more dense than the gold.
What is the same between the sun and the golden statue that was there, that was used there? The one that is the same is what?
The volume.
But you remember, density is defined as what?
Mass over volume.
So
the mass was the same, but the volume was different.
The mass is the same, but the volume is different. I think
it would
so.
be the mass.
I think the one that is the same is this one.
Yeah, because like the way
Look at the
sand
size.
is built up, it doesn't go. I can't articulate myself currently right this moment.
Okay, so try to look at this way. They have the same space that they occupy, right? So what's the space? The volume that they have. But a gold versus what? A sun?
Sand. It's rock.
Their density is not the same. So which one do you think has a higher density?
The gold.
The gold.
The gold. So if it has a higher density, that means it has a higher
mass.
Because the volume is the only one that's staying.
Why didn't he just use a rock?
I don't know. I didn't write the script. Okay?
I'm playing my man's downfall.
So, what does it tell us about this, what we call density? So, density is how packed a material is in a given volume. Okay? So just like we could say, they must have the same mass, but their volume might be different. So I may ask you the question, which is heavier? A 1 gram of gold or a 1 gram of feathers? What is your answer?
They're both the same.
They're both the same. They're both 1 gram. But if you're going to look at the volume, maybe a 1 gram of gold will just be like very small, but 1 gram of feathers might cover the whole room because the density of the feather is so small or so low. Okay? So for you to pack 1 gram of that, you have to have a lot of volume of the feathers. So that's how you define density. So let's try to solve density problem. So a sample of the mineral galena, which is lead sulfide, weighs 12.4 grams and has a volume of 164 cubic centimeter. Okay, so what is the density of the given mineral? So the way that you're going to do it is you have to define density. So density is mass over volume. And then you're going to replace mass and volume with the given value that you have. And then you're going to write the answer. You do the calculation and then write the final answer.
I think I got it.
So what's the answer that you will have here?
7.56.
2.56 grams over centimeters cubed.
So it will be equals to 7.56 gram per cubic centimeter.
Yes.
So question? Before we have the fourth question?
Is there a reason why it doesn't have, oh, never mind. I see 3 significant figures. Never mind. Sorry.
Look at my boy, using his big brain.
Okay. So we're ready for the fourth question? What, 30 seconds maybe?
30 seconds?
Yeah.
Oh my God.
90
There's no
seconds.
calculation.
10 seconds.
Like a 9.
No.
It's not a calculation. It's a straightforward one.
Okay, I'm not gonna trust you.
Okay, so next question. 30 seconds.
Oh.
Okay, 10, 5, 4. What's the magic number?
7.
7.
Okay, so there are 7 SI units. So this is improved now. It's 80%. That is correct now. Okay, so another one. 30 seconds also. Okay, 1, 2, go. Five, 3, 2, 1. Okay, it's also improved. So 90% got it correctly. So the answer there should be in Kelvin.
I missed the dog.
Okay, so what can we say about this density in terms of the properties? So we learned already about physical and chemical properties. So today we also going to learn another term for properties. So it has something to do with intensive and extensive properties. So when we're talking about extensive property, okay, this is a property that is proportional to the size of the used sample. So what does it mean? This property increases or decreases depending on the size. So mass, volume, length, surface, they are all examples of extensive properties. Now, intensive properties, on the other hand, okay, this is a property that is not dependent on the size. It's not proportional to the used sample of the given material. So whatever the size of the given sample, this property will always remain the same. Example of this is the density. Okay. Another example maybe of the intensive properties is the temperature, like the boiling point, the melting point. So when you say water, the boiling point of water is always 100 degrees Celsius. Either you have what, 1 liter or 100 liter of water. The color will always remain the same, whether you have a big size or a small size. And they said intensive property, if it's a derived unit, it came from an operation of two extensive property, like density is equals to what? Mass over volume. As the mass increases, the corresponding volume also increases, so your density will remain the same. So if you have a 20 ml water, it will weigh what? 20 grams. If you have a 10 ml of water, it weighs 10 grams. So the density will always be 1 gram per ml. Okay? Are we clear on that? Before we go on the I think the most important calculation that we have here in this course, the dimensional analysis. So how are you going to solve mathematical problems? Okay. Once you master this one, you will have no problem in doing calculation problems, at least in chemistry and in physics. Okay. The so-called dimensional analysis. So when you do calculation, it is a good practice to associate units with each quantity. Okay, so the advantage of this approach is that the units for the answer will come out of the calculation. And if you mess up in arranging the factors in the calculation, it will be apparent because you will find the final units to be nonsense. Okay, for example, if you want to convert, let's say, 20 yards to feet. So the first thing that you're going to do is put the given unit. And the given unit is what? Yards. So what is the desired unit that you have based on the given problem?
Feet.
Feet.
Someone else, could you go back one slide?
Okay. So the way that we're going to look at this one is, how are we going to go from the yard to feet? Okay. So the way that we're going to do the dimensional analysis, this is just a factor labeled method. So here we have to find a way wherein we're going to cancel the yard, and at the same time we're going to have the feet. So what's the thing that we need to learn? What's the relationship of yard with feet? So for every 1 yard, how many foot or feet do we have?
3.
3.
So the way that we're going to rearrange them here is, so we have 3 feet here for every 1 yard. So what will happen if we're going to do the operation here? Can we cancel the yard here and the yard here?
Yes.
Yes, giving us with the unit of feet. And once we have the desired unit that we have there, we can just do the appropriate calculation. That is what? 20 times 3.
Yes, it is.
So we can say it is 20 yards is equivalent to what? 60 feet. Now, as you could see here, you'll notice the cancellation of the given unit, giving you the desired unit. Now, if you're going to apply the significant figures here, again, these are what? These are
they're
exact
exact.
numbers. So usually whatever the given number that you have there, you just express it with the same significant figures as the given number. The final answer will have the same significant figures as the given number. Because the conversion factor is defined, so we could say it is an exact number. Okay? So what are the stuff that you need to know here? So usually it is the conversion factor. That's the one that will lead you, okay, to the right path. So that the conversion factor method may be used to convert any unit to another, provided a conversion equation exists. And usually there's a relationship between certain imperial system or English system and metric system. Some of these are the one that we have here.
You suggest we memorize them, right?
I would say no.
No.
Because the way I want this class to be is not on memorization. Maybe you take another course that is more on memorization. You will be given a periodic table, and if you're given a calculation like this, you'll be given the conversion right away.
Thank you.
Okay? We will be given all the chances to pass the course. That's why if you fail, I have all the reasons to fail you. It's just as simple as that. Okay? So what does this mean? So if I want to convert a mile to a kilometer, or we could say a centimeter, how is the pathway that I'm going to build? So maybe in the mile, I multiply it with what? Whatever corresponding kilometer that I have here. Right? And then what? Maybe in a kilometer, if I know the centimeter, fine. But if not, what will I do? Maybe I use a meter. Okay? And then I multiply it. So in 1 meter, how many centimeter? Is it 10? So if I'm going to what we call do the calculation, what do I need to do? I just need to see if I can do a calculation among the units where I can cancel them out. Because one here is a numerator and the one here is a denominator. One here is a numerator and this one is a denominator. And one is a numerator and this one is a denominator. So I end up with the final unit that I want. When we go to mole concept, you're going to apply the same thing. Because if I rearrange something here, like I mess up, I put it like this. So let's say I just want to go to kilometer. So if I rearrange it this way, what will happen? What's the unit that I will have? Miles squared over kilometer. Which what? Doesn't make sense. So this is how you do the calculation. And I'm going to give some example of this calculation as we end this chapter today. Okay. So I have some calculation in the end, or maybe we can put an additional problem. So let's try to do this one. It's not in your slide. So how am I going to solve this problem?
You convert milliliters to liters.
Okay. So you're asked for the density of oil in wintergreen. So density is just equals to what?
Mass over volume.
Mass over volume. So right away, if you just put what? 28.1 gram divided by 23.7 ml. And then that's it. So what's the answer?
$1.19.
So you're going to get the 1.1856 if you're going to round it up.
Wow.
1.19 grams per ml.
Yes. I agree.
So if I'm going to go, it's around 1.19. So I try to look at the conversion that we have here. I know here, so maybe this one. This is a conversion problem. So a sample of sodium metal is burned in chlorine gas, producing 573 milligram of sodium chloride. So how many grams and kilograms is this? So usually as somebody asks if you need to memorize, so usually this is the type of questions that you will be given. You will be given the conversion.
1 milligram.
So we don't have to remember either the pico, the kilo.
No. So if we're going to solve this, we start with what? 573? And then maybe use for every, where will I put the milligram here? Top, bottom?
Bottom.
Bottom.
And then for the other one, I could do 573 milligram times 1 milligram, 1 times 10 to the 3 grams times 1 times 10 to the 3 grams, 1 kilogram. So this unit will give me gram, and this unit will give me kilogram, this calculation.
I got 0.573 for grams. That's wrong. Okay.
So how many grams?
0.573.
Okay, so 0.573. How about the other one here? How many kilogram? Anyone?
It's a lot of zeros. I'm not sure. I got
5.73 times 10 to the negative 4.
Yes.
So if you're going to look at this, the milligram is cancelled here. The milligram is cancelled here, and then the gram is cancelled here, leaving you a kilogram. Question.
Yeah, why is it the second one 5.73?
That's how you do scientific notation.
You have to, do it in terms of scientific notation.
Okay.
Because the number is 0.000573. That's the answer that you will get there like this.
So you move the decimal that many times.
No, I'm talking about like the first part where like at the beginning of that.
That's.
Oh, this one?
No.
No, the
bottom. So you wrote two things, and the second one you started with 5.73.
Oh, it should be 573. That's my mistake. Sorry. Analyze.
What do you mean analyze?
If you have any question.
Oh no. Sorry.
The other class.
I do actually have a question. I think you already answered it, but I just want to be absolutely positively correct. Will you give us conversions like this in a problem? Or okay.
But we do need to remember the SI basis, right?
Yeah.
Or you said.
You might have a question like that.
Okay.
Now, the 4 questions that I have, some of them might come out as your question in the exam. This is I can tell you. I'm going to give all opportunities for you to pass the course. So if you still fail, then I have all the reasons to fail you.
Thank you.
So the questions that I have in the 4 questions, the questions that I have in this, what we call the chapter quiz, most of them are similar to the question that you will have in the exam. So it's fine for me if you don't get it correctly, but if you still don't get it during the exam, then that's not a good reflection on yours. Remember, in baseball, how many chances does the batter has before he struck out?
3.
Yeah. So here for you, at least, you might give what? At most 3 or 2. So I'm hoping that by the second time, you already learned the type of questions that was given to you the first time around. Okay? Question?
No questions.
Nope.
Before I get the quote of the day, and then I'm going to show you a video of this quote of the day, because I get this, if you're going to look at the, only you can change yourself. I got it from a Thai weight loss commercial that you're going to see right now. Where is it? Just look at the
บนเขามีบ่อน้ำศักดิ์สิทธิ์ตำนานเล่าว่าผู้ใดแบกน้ำขึ้นไปเติมให้เต็มเทพเจ้าจะปรากฏมามอบพรวิเศษ
So
Major Gift 711
So I hope you be like the person in the commercial. Okay. Oh wait, not that one. So what does this mean? I want you to have an attitude. Quiet.
Sometimes you
I'm going
got
to mute you. Okay. So this is the thing. If you come here to learn, most likely you will learn. But if you come here expecting a grade of A, B, or C, I'll tell you, you're going to be disappointed. Okay? So every time we meet, I want you to have an open mind. Okay? A mind that says, I want to learn something. Because if you're going to have that attitude, you're going to learn something and the grade will be much easier. So in the commercial, what's the goal that was given to the lady?
To fill the well.
Anyone? Now you can unmute yourself.
To lose weight.
Yeah. What's the goal that was given to the lady?
To fill the well so she could be happy.
Huh?
To fill the well so she could see a God that could be happy.
You have to fill the well. Okay? So how it is synonymous to you? You have to fill your own well. What is your own well? What is the well that I asked you to fill up with? Anyone?
Knowledge of chemistry.
Knowledge of chemistry. Okay? So I want you to do that every time that we meet is we have to fill up that knowledge of chemistry that you have to fill up your well. What does the course say? Chemistry. What does our mantra say at the beginning? The letters in the word chemistry, right? Chemistry. Right? And usually you, sometimes, just like my children, my high school kid, he had his own way. So if you want your own way, yes, the letters will rearrange. And in the end, you will know what the other letters will come out with. Okay? So I want you to do the part. I would say you put your trust in me. Okay? I know what I'm doing. I've been doing it since before. This is what? My 22nd years of teaching. And students who follow what I ask them to do usually do well. But students who want it their way, well, it's a free country. Okay? I cannot force you to do what I ask you to do, but there might be some consequence on that. Okay? So whatever you heard about the course or about me, remember, those who said that are ones like you. So most likely those who get A, they were happy with me. Those who didn't do well, they were mad at me. But the thing is, I'm going to do the same way, and it's up to do it your way. Okay? All I can promise is I'm going to do my part to prepare you. But you also have to do your part. Okay? So do you have any question?
No, all good.
No, thank
you.
So please start doing your stuff. Okay?
Got it.
Please start doing what? The Alex? Oh, not the owl?
Yes.
Okay, if you have to attend the class to do the poll survey, please do it. Okay?
Okay. Okay.
So any more questions? And don't hesitate to email me. Sometimes I might forget to answer. You can email me back because I get what, 100 emails every day. And sometimes some of them are not even important ones, being spammed by a lot of emails. And try also to answer the what we call discussion forum. Okay, I only have, I think, 80 and 70 students who have answered the discussion forum. So please answer the questions there. Okay, so any more questions?
Nope.
No, that's it.
Okay, so see you on Thursday.
Thank you.
Thank you. Bye. So much.
Bye.
Have a good day.
Bye.
To stay safe.
Good day, Professor.
You too.
Partying yet, okay?
Thank you.
Get the next question, Greg?
Yes.
Hello.